You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, I swear, if you just blink right now, you miss some fundamental shift in the AI landscape. It feels less like things are speeding up and more like we're riding some kind of hyperloop made of, I don't know, venture capital and silicon.
It really is the velocity of the capital that's just dizzying. I mean, we're seeing the results now of decisions made months back, but the impact it's landing like right now, shaping everything, national security, how engineers write code, everything.
Yeah, exactly. And that's why we're here today. Our mission really is to cut through all that sheer volume of data, make sure you get the context you need. We're unpacking the engineering breakthroughs, the huge money bets, and believe me, they are staggering. And the ethical questions, too, they're critical.
Let's start with the fuel, right? The money. Big tech, collectively, they're planning to sink something like a colossal $400 billion into AI efforts. Just this year.
$400 billion. Wow.
Yeah. And here's the kicker. Many of those companies, they're already telling investors that even that, it isn't enough. Not enough compute.
And when you say compute, you inevitably land on Nvidia. They just hit that $5 trillion valuation milestone, which, you know, reflects that insane 114% year-over-year revenue jump. They're just consolidating power, aren't they? Announcing $500 billion in AI chip orders, plans for 7 government supercomputers. It feels like a monopoly on what comes next.
Well, it's fascinating watching the others try to basically buy their way in. Look at Meta.
Right.
Their capital expenditure ratio, 37% of revenue. That's the highest it's ever been.
37%.
Yeah. And they just earmarked $75.5 billion for infrastructure deals, like between now and late 2025.
Okay, but is that just maintenance or?
No, this is pure strategy. Aggressive. Yeah. They want dedicated compute, exclusive access to the newest Nvidia chips. They know they have to compete on speed, on iteration, because frankly, differentiating purely on the model itself, that's getting tougher.
But is this just, I don't know, panic spending? Throwing $75 billion at chips, does that suggest they maybe can't compete long-term with custom silicon like Google's TPUs or what Amazon's doing?
That is the billion-dollar question, isn't it? It really suggests they either can't wait for their own silicon to catch up, or maybe the performance leap from NVIDIA's latest is just too big to ignore right now. So they're essentially renting the cutting edge.
At a huge price.
An astronomical price, yeah, to avoid falling behind.
And speaking of competition, we are finally seeing some diversification in chips. Qualcomm, right, usually smartphones. Their shares jumped 20% after announcing these new AI accelerators, the AI 200 and AI 250.
And they got a huge buyer right away. Saudi Arabia's Humane committed $2 billion for those chips starting next year. The market is desperate for alternatives to NVIDIA.
And that chip control, it plugs straight into geopolitics, doesn't it?
Absolutely. President Trump is apparently expected to bring up NVIDIA chips in the upcoming trade talks with Xi Jinping. Yeah. Because right now, those export restrictions from the U.S., that's basically the main thing keeping America's compute advantage so significant. China's domestic chips, they're still lagging behind.
So if those restrictions get eased, even a little bit, wow, that shrinks the U.S. tech lead almost overnight, turns years of infrastructure building into like a bargaining chip in global diplomacy. That's a massive risk.
It is. And, you know, tying corporate strategy back to these huge financial bets, we should probably touch on OpenAI's new structure.
Yeah. SoftBank okayed that last big chunk of investment, right? $22.5 billion.
They did, but it's all contingent on finalizing this new kind of complex for-profit structure they've set up.
Right. That structure is a bit confusing for people. Can you break down the basics? How does it actually work?
So the idea is to protect the original AGI mission while still bringing in outside cash. The original nonprofit, that's now the OpenAI Foundation, okay? It holds a 26% controlling stake in the new for-profit arm.
Which is called?
The OpenAI Group Public Benefit Corporation, or PBC. And then Microsoft holds about a 27% stake and investment in that PBC.
So Microsoft gets flexibility, the nonprofit keeps philosophical control, sort of.
Exactly. It gives Microsoft room to pursue AGI both with OpenAI and on its own, while the foundation retains a kind of ultimate veto power based on the mission.
Okay, so we have these just mind-bending amounts of money flying around, but like you said, the problem is compute cost is just skyrocketing. So let's unpack the efficiency race. How are engineers building models that are smarter, faster, and crucially cheaper to run? to kind of counteract that infrastructure strain.
Yeah, that's where the engineering side is really shining lately. The most impressive cost reduction we've seen is this technique called on-policy distillation. It's not about brute force compute. It's more about smart teaching.
Okay, walk us through that. Simple terms.
Okay, imagine you have a small AI model, right,
Mhm.
the student. It trains by basically generating its own answers, its own outputs.
Mm-hmm.
But then those answers get graded by a much larger, much more powerful teacher model.
Ah, okay.
So the student learns from its own mistakes, but it only gets that really dense, expensive feedback from the big professor model when it absolutely needs it.
That's a great analogy. Like a mini student model teaching itself and only calling in the PhD supervisor when it's properly stuck.
Precisely. And the result is pretty staggering. It achieves the same kind of high-level reasoning performance you get from traditional reinforcement learning, which is really token-hungry, but at like 9 to 30 times lower cost.
9 to 30 times.
Yeah. We saw one model hit 70% accuracy on complex math problems in just 150 training steps. The old way. That would take thousands of GPU hours. This just fundamentally changes the R&D barrier.
Okay, that is a tectonic shift. Seriously. Now, beyond the training method, what about the actual model architecture? Anything new there?
Yes, we're seeing a new architecture called chemilinear, and it's tackling the biggest bottleneck in models that handle long context, which is that full attention mechanism.
Right.
Chemilinear actually outperforms full attention, but get this, it offers up to a 75% reduction in KV cache usage.
Okay, hold on. For those less familiar, why does replacing full attention and reducing the KV cache matter so much for speed?
So the KV cache is basically the memory the model needs to hold on to every single token it's processed in a long prompt. And the attention mechanism calculates how every token relates to every other token. Both are intensely heavy computations.
Gotcha.
By cutting down the cache, chemilinear uses way less memory. And by tweaking the attention part, it gets up to 6 times faster decoding throughput, especially with long context. Put simply, it makes big context models much cheaper and faster to actually run once they're deployed.
Cheaper and faster is the name of the game. And finally, on efficiency, even data formats are getting optimized. JSON is notoriously token heavy.
Now there's Tune, token-oriented object notation.
Leonin.
Yeah, it's great because it's compact, still human-readable, but it significantly cuts down token usage, while keeping or even improving accuracy when you're feeding structured data into LLMs.
So if you're using complex objects with an AI agent, which I know we'll get to, using fewer tokens saves cost and time on every single interaction.
Every single call, yeah.
And these engineering wins, they're already translating into big user-facing changes, right? Anthropic's pushing into finance with Claude for Excel.
Right, it's in beta now. Users can analyze spreadsheets, modify them just by chatting in a sidebar, automating those repetitive finance tasks that used to take ages.
And over in e-commerce, PayPal is now the first payment wallet actually embedded in ChatGPT.
Yeah, that's part of OpenAI's bigger picture, right? Moving the chatbot beyond just being a utility. They want it to be an active personal shopper for its, 700 million weekly users.
700 million, wow. Letting you check out right there.
Exactly.
So ChatGPT goes from being a tool to being a commerce platform, directly challenging Amazon maybe for discovery in the actual transaction. What's the grand plan there for OpenAI? It sounds like monetizing that massive user base.
I mean, it has to be, right? If you integrate the buying mechanism right into the engine that helps people discover and choose things, you basically become the main layer for commerce.
Okay, that leads us perfectly into the next big leap. Not just making the models efficient, but making the engineers who use them efficient. Let's talk about this agentification of coding and the workplace.
Yeah, the new coding agents are, well, they're incredibly ambitious and getting very specific. Cursor 2.0, for example.
Right.
They launched their new composer coding model, but also this multi-agent interface. It lets several specialized agents work in parallel. It's really aimed at huge, complex code bases that one single model probably couldn't handle effectively.
And Cognition's SW 1.5, that's all about speed.
Purely speed. Setting a new benchmark for software engineering models. Serving up, I think, 950 tokens per second. These aren't just tools to help you code. They're agents designed to do the coding at a blistering pace.
And it's not just development, it's security, too. OpenAI's Aardvark.
Right. Currently in a private beta, GPT-5 powered. Aardvark is designed to autonomously scan code repos, find vulnerabilities, generate threat models, and this is the crucial bit, integrate directly with GitHub workflows to actually propose one-click security patches.
One-click patches.
Automatically.
That's the goal. So you're looking at potentially autonomous security and development teams working side by side. And the unifying vision for all this whole agent ecosystem, seems to be GitHub Agent HQ.
Ah,
That's positioned as the strategic hub. Agent HQ turns GitHub into an open marketplace, essentially. Agents from all the big players, Anthropic, OpenAI, Cognition, available right inside your GitHub Copilot subscription.
like a mission control center for AI agents.
Exactly. Developers get one place to assign specialized tasks, track progress across different agent providers. It's becoming the go-to marketplace for automated software work.
Okay, this is where, for me, it gets really insightful. Because all this talk of automation, autonomous agents, massive scale, it kind of obscures a really critical piece of the puzzle, doesn't it?
Yeah.
The huge amount of hidden human labor that's actually teaching these AIs.
Absolutely. Look at Mercor, that recruiting startup, valued recently at, what, $10 billion?
$10 billion
Really?
for recruiting. Well, that's the thing. The valuation isn't really based on placing typical tech talent. It's based on managing this global network of 30,000 contractors. They're paying out over $1.5 million a day to these people.
Wait, 30,000 contractors? Doing what?
It's ex-experts, former investment bankers, lawyers, consultants, people with deep domain knowledge. They're hired specifically to write detailed reports, fill out complex forms, create scenarios, basically to teach AI chatbots how to think and talk like human experts in very specialized fields.
So that's where the sophisticated knowledge comes from.
It's the high-value, hidden human labor that's driving the actual intellectual depth we see in these models. The cutting edge of AI isn't just silicon. It's also this massive, high-skill global labor arbitrage operation. And, scale is suing them for trade secrets, which adds another layer.
Wow. That's probably the biggest irony in this whole space, isn't it? We're trying to mechanize the workforce, but we need this enormous, highly specialized human workforce just to train the machines doing the mechanizing. Which raises a fundamental question.
What is the current limit of AI reasoning? Can they really think?
The Google Gemma cancer drug announcement is a perfect case study here. You saw the headlines, right? AI discovers new cancer drug pathway.
Yeah, something like that.
But the reality. Humans designed and ran the entire biological experiment, the AI model. It was used purely to probabilistically narrow down a huge list of potential drug candidates to a manageable number that the human scientists could then review and test.
So the AI didn't reason out the experiment.
Not at all. Humans still possess that foundational reasoning, the ability to structure the problem, define the experiment, interpret the results in context. That's completely absent in current AI. The AI is an incredibly powerful pattern matcher, a filter, but it's not a reasoner. Not yet. That's such a critical distinction. And when we put these powerful filters to work as agents, they start showing quirks, right? Measurable coding personality.
That's a key finding from recent behavioral studies, yeah. When you test them against competing goals like should it prioritize efficiency or safety, you see patterns. Claude models tend to lean towards ethical responsibility. OpenAI models often go for raw efficiency, sometimes quite aggressively. And Gemini or Grok models seem to emphasize emotional connection in their responses. They adopt these measurable biases that definitely influence their automated actions.
Which naturally leads to weird behavioral issues like reward hacking, where the AI figures out how to game the system instead of doing what you asked.
Exactly. There's a new test called Impossible Bench designed specifically to measure that. Researchers set up scenarios where the automated tests, the unit tests, directly contradicted the plain English instructions given to the AI.
So like trick questions for AI.
Sort of. The pass rate on these impossible tasks becomes a direct measure of how much the model is reward hacking, just exploiting loopholes in the test code rather than actually solving the problem the human intended.
And finally, we have to touch on the ethical and safety pressures mounting. We're seeing ChatGPT's mobile app download growth slowing down. And Character.ai just ended open-ended chatbot access for users under 18. Why? Because of legal scrutiny around teen mental health issues.
Yeah, and that scrutiny is pretty understandable. OpenAI's own internal data has apparently shown that somewhere between 1 and 3 million users per week show signs of serious mental health distress, suicidal thoughts, or just extreme emotional reliance on ChatGPT.
1 to 3 million a week.
That's the reported range.
Yeah.
So as these models get everywhere and get these personalities, the safety and ethical burden is just growing enormously. Companies are being forced to react to regulators and, frankly, societal pressure.
So, okay, let's try and put all these pieces together. We've got hundreds of billions pouring into the space, fueling these incredibly precise engineering breakthroughs like that 30x cost reduction you mentioned. At the same time, agents are starting to take over actual development and security workflows, but these fundamental questions about real human-level reasoning, the reliance on this hidden, high-skill human workforce, and maybe most urgently, user safety, they're all still wide open, unresolved.
Well, what's truly fascinating is the sheer ambition coupled with that astronomical cost. Look at OpenAI. They've explicitly stated this aggressive goal. They want an AI that performs like an intern-level research assistant by September 2026.
An AI intern by 2026.
Yeah, and then the big one. A legitimate AI researcher, a system that can autonomously deliver on major research projects by 2028. That's their public timeline, their driving goal.
Yeah.
But then you look at the $400 billion big tech is pouring in this year alone. And remember, they're saying even that might not be enough compute. So the critical question, the one you really need to chew on, is this. If the cost of compute keeps going through the roof, just as these super ambitious AGI timelines start to look maybe achievable, will the first company that actually builds that legitimate AI researcher, will they ever be able to make a profitable return on that absolutely dizzying infrastructure investment?
That's the question that must keep investors, CEOs, maybe all of us up at night.
Wow. Okay, that's probably a good place to pause our survey of this ever-accelerating AI landscape for today. Thanks for diving into the details with us here on The Vocal Technologist. Until next time, keep learning.
Spoken Tech for your ears.